Welcome guys to today's class. In today's class, we want to see how to solve these problems we have. These questions you are seeing are coming from an important topic in chemistry called buffer solutions. Yes, what do you know about buffer solution? I would like to tell you that buffer solution is any solution whose pH resists to change on addition of small quantity of acid or base. Yes, remember, on small addition of acid or base. So if you carry large quantity of acid or base and pour into it, it will change. The pH will definitely change. So it's only when you add the acid or the base in small or little quantity, that is when it resists the change of its pH. Okay, so we say buffer solution, they are solution whose pH resists to change on addition of little quantity of acid or base. These buffer solutions have been used in the medicine, in laboratory, in fact in science. If you check malaria test case, you will see that it make use of what? Buffer solution. They use it to do the test. If you check COVID-19 test case, they also make use of buffer in running the test. So these buffer solutions have good application in the field of science. Now, this buffer solution can be divided into two: acidic buffer and basic buffer. Remember, I said can be divided into two. That doesn't mean that we don't have other types, but we say we want to classify them into two: acidic buffer and basic buffer. When do we, or what do we mean by a buffer being called acidic buffer? When do we call an acidic buffer an acidic buffer? When do we call a given buffer an acidic buffer, so to speak? That means if you have a buffer that contains acidic buffer is any buffer that contains an acid and its conjugate base. We call them what? An acidic buffer, so to speak. What do we mean? This is an example of an acid, a weak organic acid, ethanoic acid. Then this is an example of conjugate base of it, sodium ethanoate, so to speak. When you have a solution containing this and this, we call that solution acidic buffer or acid buffer. Are you getting it? When do we call a buffer solution basic buffer? When do we call a buffer solution basic buffer? It means it contains a base and its conjugate acid. Conjugate acid. Example, ammonium hydroxide and what? Ammonium what? Chloride. This is the conjugate acid of what? Ammonium hydroxide, and ammonium is the base. So when you have this type of what? Combinations, we can call it acid buffer, basic buffer. Now, it's important that when you are solving question on buffer, likely questions you can be seeing is pH. Find the pH of this buffer. What do we mean by pH of a buffer? It means the measure of what? The degree of acidity or alkalinity of that what? Buffer. The measure of the degree of acidity or alkalinity of the what? Buffer. We'll call it pH of that buffer. Are you getting it? Now, when we want to find pH of acid buffer, it means that when we say pKa plus log concentration of the what? Salt or over concentration of the acid. Now, we can also get pOH of a what? pOH of a what? Basic buffer. We are talking about POH because every basic buffer, most of them have what? OH group. Now, we say it is pKb plus log what? Salt over base. Now, I want to let you know that use of mathematics can be applied here. There are a lot of mathematical work they can use to confuse us here. If you check in some textbook, they can say pKa minus log. Once you put minus here, it means you invert this. It becomes acid over salt. So when you see pH of acidic buffer go this way or this way, know that they are saying the same thing. Likewise, this pH of basic buffer, pKb minus what? Log of what? Base over salt. It is just mathematics. Once you put minus here, you change here. Once you put plus here, it goes this way. Now, it's important for you to know that POH plus pH equals to pKw. Yes, when you hear POH, it means minus log of what? OH. When you hear pH, it means minus log of what? H. So minus log in this topic is called P. Minus log is called P. Then pKw also minus log of Kw. That is the ionization constant of the water. Minus log of the ionization constant of the water. All these things are coming from the topic of ionic and chemical equilibrium in chemistry. So I want you guys to note that minus log of OH means POH. Minus log of hydrogen ion means what? pH. Minus log of Kw means pKw. Note it. So when you add the what? POH with pH, you have pKw. Then when you multiply OH ion with what? Hydrogen ion, you'll be getting 10 raised power minus 14. That is when you multiply them. You have to be noting this formula. Then when you have pKa plus pKb, you will be having it to be pKw. And note that pKw is equals to 14. It's constant. pKw is constant, is equals to 14. Now I want to see how to solve this problem we have on the board. I haven't noted important points on buffer. Yes, remember their pH resists to change on addition of small quantity of acid or base. Let's see how to solve this problem we have on the board. Question 1. What is the hydrogen ion concentration? This bracket, close bracket means concentration. What is the hydrogen ion concentration in mole per liter of a solution 0.2 mole per dm cube in this and 0.1 mole in this? So what they mean by in this mean 0.8 of what? And this of what? They are telling you the concentration of the sodium ethanol, which is the salt, and of the what? The acid. Now, for you to solve it, they gave you the Ka. You tell them that pH is equals to minus log of what? Hydrogen ion concentration, and is equals to what is the pH of this buffer? Is this a buffer or not? How do I know whether this is a buffer? You can call this a buffer because it has an acid and its conjugate base. Because we say acidic buffer is a buffer solution that have an acid with its conjugate base. And so this is an acidic buffer, so to speak. So we now say is equals to log what? Is equals to pKa plus log what? Salt over acid. As we said, what is our pKa? pKa wasn't given. They gave us our K. That means to get our pKa, we will tell them that since Ka is this, pKa is minus log of Ka equals to pKa equals to minus log of what? 1.8 times 10 raised to power minus 5. Then we press it in the calculator, minus log 1.8 times 10 raised to power of minus 5. So that gives us 4.745 answer. That is our what? pKa. I will put it here. Since pH is this, I will now say minus log of hydrogen ion concentration, which is your pH, is equals to what? 4.745 plus log what? What is the salt? Quantity of salt? 0.2 all over 0.2. Can you see it now? That is acid, concentration of acid and salt and acid, so to speak. 0.2 over 0.2 will give you 1. Logarithm of 1. Remember when you see log, log means in base 10, a standard base. Are you getting it? So 0.2 over 0.2 will give you 1. Log 1 to base 10 is 0 in mathematics. Please, log 1 to base 10 is 0. Let's write it. Log 1 to base 10 is 0. I will now say that this is minus log of what? Hydrogen ion concentration equals to 4.745 plus 0. This. Now, remember we say minus log means it is in base 10. Now, I will say take this minus, take it to the other side. It will be log hydrogen ion concentration in base 10 equals to. So that means anytime you see ordinary log without a base, it means it is in base 10. It is a natural base. Just have that secret at heart. Now, this one now, I will take this minus to this side, become minus 4.745. Then the hydrogen ion concentration, making it subject to formula, this 10 will lift this up from principle of how to convert logarithm to indices. So to remove this logarithm, this 10 will lift this up, equals to 10 raised to power minus 4.745. So I will be having 10 raised to power of minus 4.745. The answer will now be 1.799 times 10 raised to power minus 5 mole per dm cube. And mole per dm cube means mole per liter. Mole per dm cube means mole per liter because 1 dm cube is equal to 1 liter. So that means our hydrogen ion concentration in mole per liter will be equal to 1.799 times 10 raised to power minus 5 mole per liter. That becomes your answer to question number 1.